Alright, so they want us to graph two periods of the sine wave. Shouldn't be too bad. So the first thing we need to do is get the period. The period. For a normal sine wave, the period when we have just x is 2 pi. But in this case, we don't have just x. We have 3 pi x. And so still 3 pi x, still 2 pi. But now the period is different because we need to solve for x. So if I cut pi from both sides and move the 3 to the bottom, I have x equals 2/3. So my period is equal to 2 over 3. Now, phase shift. The way I do the phase shift, the book says factor and then blah blah. No, I don't factor. I solve for x. I put 3 pi x minus pi over 6 equals 0. So that means I can do 3 pi x equals pi over 6. So I can cut pi from both sides, and I have x equals 1 over 18. So the phase shift equals 1 over 18. And you know what? Now I need to cut my period into 4 parts. Well, first let's put the phase shift mark before we forget. So the phase shift, we start like right there. That would be, I'm going to put it in red. So 1 over 18 is my phase shift. Now I'm going to calculate my increments so I can draw my quarters. So my increments, I need to divide the period by 4. So 2 over 3 divided by 4 is the same thing as multiplying by 1 over 4. So that'll be 2 over 12. So the quarter is 2 over 12. Okay, so I'm going to be adding 2 over 12 to starting at 118. So 118 plus 2 over 12 plus 2 over 12. It's better if I convert everything to a common fraction, so a common denominator. So 18 and 12, the common denominator that they share is actually 36. So I'm going to convert this guy to 36, so it's actually 236. So actually 236. Now I'm going to convert up my quarters to 36. So multiply by 3. So 12 times 3 is 36. 2 times 3 equals 6. So I need to be adding 6 over 36. Okay, that's pretty easy. I have 2 and I add 6 more. So now I have 836. Then I add 6 more and I have 1436. And I add 6 more and I have 2036. See, I don't have to be converting each time. And then I have 2636. 1, 2, 3. 2636. So I got all my markings. And I can actually now draw my sine wave because I know the amplitude is 2. And I take it right there. That's 2. So that'll be 2 here and 2 at the bottom. So remember, always start the phase shift. Don't start at the origin, the phase shift. So I started the phase shift. So my first quarter goes to the amplitude. Second quarter goes back to the x-intercept. Third quarter goes to the amplitude. And the last quarter goes back to the x-intercept. So that's my first period. And then you say, well, but you need to do another period and you don't have any room to go on the right. I say, that's okay. The periodic wave is continuous. It goes all the way to the right, all the way to the left, forever until you turn off the machine. Okay. So how do you extend it to the left side? Same principle. We're going to be subtracting 6 when you go to the left, you are subtracting 6 36. So I have 236 and I subtract 6 and I got negative 436. So negative 436, negative 436. And then I subtract 6 more, so I have negative 1036. And then I subtract 6 more, I have negative 1636. And finally, 6 more, I have 22, negative 2236. So now I have the material to draw another period. So I'm at the x-intercept, so now I want to go again back to my amplitude. So right there, then back to my x-intercept, then to my amplitude, and back to my x-intercept. So now I have two periods. 1, 2. Cool. Now they want me to find the intercepts and asymptotes. Well, there is no asymptotes, but we have some intercepts. We have an x-intercept here, an x-intercept here, 1x here, 1x here, 1x here. For y, we only have this one, because the graph only crosses the y-axis one time. Okay, it crosses the or touches the x-axis on several places, but the y-axis only gets crossed once. Okay, so let's get the x-intercept. So now I'm going to do some conversion so I give you the right fraction. So this one is an x-intercept, so that's minus 11/18. This one's another x-intercept, so I have minus 5/18. And this one is another, remember we used to have 1/18. And then that's another one, we have 7/18. And that's the last x-intercept, I have 13/18. And you can erase the converted ones if you want, I can just get rid of them. It's up to you. Whatever your teacher requires. Well, at least that's my method. Okay, like I said, we have one y-intercept, which is right there. How do you calculate the y-intercept? The y-intercept, you start with the original function, y equals 2 sine. So at the y-intercept, x equals 0, so all this is going to be 0, so that's going to be minus pi over 6. So this is the same thing as y equals minus 2 sine of pi over 6. I know that pi over 6 is equal to 1/2, so now I have minus 2 times 1/2, so that's equal to negative 1. And that should be equal to negative 1. Okay, so I think we got it all. Thank you for watching.